Hello folks, I had a video of me soldering this thing up, and there's a ton of them on YouTube, and so I decided to go a little bit different direction. Kind of explain this thing a little bit. I've I'm the type of person who, when I was a kid, always taking my my toys apart, and always interested in motors, and rebuilding old junk go-karts and mopeds and four-wheelers. And when I got older, I was into cars and rebuilding cars and making them fast. And now I took an interest in electronics, and I just, it's fascinating. I've even the little simple circuit that's in here, the Astable multi-vibrator, which is basically just an oscillator, is you can get on there and watch some very highly educated people struggle to kind of explain how it works clearly. And so yeah, I find that fascinating. Even something so simple, there's a whole world in it, and but we're going to take a little look at this thing and see how it works. If you look here, I'll use this as my pointer. There's two little transistors here and two caps. These two caps and these two transistors and these little resistors form a delay line, and this thing bounces back and forth, boom, 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 but it's pulling negative. These are NPN transistors. So they're pulling, low, back and forth, low. Well, every time they pull, this is a PNP, which is positive, negative, positive. So basically, this makes a positive signal through a negative signal. So basically, what it's doing is every time these oscillate back and forth, this little transistor here sends a clock, sends a high pulse. It pulls this IC high on the clock line, and it starts counting up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's little output pins here, and it basically counts up 1 to 10. These little diodes here on the side, that's what it uses to make this pattern. Or it would just be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, it wouldn't quite work out, but it uses that signal, and it uses these diodes, and it makes 6 different modes. But on the green, since it counts to 10, if you'll notice, this flashes twice. Well, it's hard to see, but I had it limited, and you could see this green LED. It will pulse twice and then go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you can't see it on camera, but that's why it hangs a little bit longer on the greens, if you'll notice, because this is 2 pulses every time it goes to green. You see that? Basically, they're only using it counting to 6, but this thing counts to 10. That's why the green hangs a little bit longer. But yeah, it's just fascinating. I find electronics fascinating. And these little kits, these little vellemen kits, are excellent to start out with. They got nice big pads on them. They're easy to solder. They're nicely laid out, and they work. This IC was actually in an anti-static foam, which I got some kits from China, and the IC is just floating around in there. This is a static sensitive component here, so yeah. And if you'll notice, this little VR right here will trim these capacitors, so one of these will fill up faster than the other. So it'll change the frequency of this vibrator. So if you turn this up, you can see it slows down, way down. And what that's doing is it's limiting the current to charge these capacitors, because every time one of these capacitors charges up, boom, it turns on the other, and when it turns that one on, it pulls this one's base down, so it has, you know, no current. But when it does that, when it pulls this to negative, it charges the opposite capacitor, begins to charge. And when this thing charges up to 0.7 volts, it flips to the other one. So you can kind of see how this is working here. And if you limit how long it takes one side of this to charge, it will not oscillate as fast. Or if you charge it faster. So if you put more resistance in line charging this capacitor, it'll slow it down. But yeah, I just, you know, you can look it up how a Astable multi-vibrator works, and you can see some people struggle with that. It's hard to get a clear explanation. I mean, I understand how it works, but you know, you'll see it. You know, it's kind of hard to get a, you know, a straight answer, which that's pretty much how it works. I mean, these things bounce back and forth, and whenever one of these capacitors charges up to 0.7 volts, it fires. It turns on this transistor, and when this transistor's on, it causes it. When it pulls this to negative, it gives there a path through this capacitor to charge it up, and when it reaches 0.7 volts, it turns this transistor on, and when this transistor turns on, it basically pulls this the pin on this low, so it forces it off, and they just bounce back and forth, boom, 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 boom. And this little VR here limits the current to how fast these capacitors charge. And this is called a decade counter. It basically it says 0 through 9. They count 0 as a number, so basically it counts to 10. Hence a decade counter. And like I said, this little BC557 just pulses from this oscillator. It turns these oscillations, these negative oscillations, into a positive clock signal, and this thing just counts up each one. You know, there's voltage that comes in on some of these pins, then there's a clock and a reset, but the output pins are just 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, which basically just counts to 10. So as this counts to 10, it goes 1, 2, so this is 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's how it works. Every time it goes to green, you'll see how much longer it takes on green. This is 2 clock frequencies. 1, 1, 2 clock frequencies. 1, 1, 2 clock frequencies. 1, 1. So, yeah. That's how it works. And very nice kit. If you're interested in building one of these, you know, it's very easy to build. And like I said, you know, if you went to a store and bought this, you know, you'd be like, you know, what the, just, you know, why? I mean, it's kind of cool, but you probably wouldn't buy this thing, right? But when you build something with your own 2 hands, you know, it gives you a little pride and a little, you know, it's nice, you know. But anyways, if you want this thing, I have a link down below. Have a good day. Just wanted to add a little something. This is my second YouTube video. You know, I'm gonna be taking a whole journey through learning electronics, and I mean, I've learned a lot already, but you know, I got a long ways to go. And if you wanna take that journey with me, you know, watch my videos and see how far I can progress over the next year. I got some really cool ideas. I'm gonna, you know, build a negative positive power supply. Um, I got a little spectrum analyzer I'm gonna build, 12 band. Um, you know, I'm just building these little kits, you know, you know, just to start out with, give you something to see, hopefully get you interested. And you know, I built a couple of these things. This right here works the exact same, only this doesn't have a counter IC. All it has is the oscillator, but works on the same principle. As you can see, same principle. You know, it's just bouncing back and forth on these two transistors here. This is called an Astable multi-vibrator. Sounds kind of whatever, multi-vibrator, but yeah, it's amazing. The same thing that's doing this is what makes this do that. You know, they're very simple, yet very complex, which is something I love about electronics. I mean, if you don't think it's complex, you know, you can look up the workings of an Astable multi-vibrator, and you'll be surprised how complex it is, just getting that little oscillation in there, which is just fabulous. You know, it's like candy for the brain. I'm a knowledge junkie, but yeah, keep watching. Have a good day.